Omniballs are a thing.
Omniballs.
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 120. Today we're talking about the epic chip shortage, VGA glitching, truly owning Roku, and Omniballs.
Starting off the news with something that's at least important to my tribe of people, Freenode. This is an IRC server network. Last week, caused quite a dust-up in the internet relay chat scene. Basically, all of their staff left and formed a new network on allegations of mismanagement. Tom Nardi wrote an article about it, and that was current as of last week, but there's something happening every day. Between then, a lot of sites said we're going to move to Libera, this new network, and it looks like any channel that had said they were going to move to the new one has gotten shut down by Freenode. What's interesting that's come out of this, though, is that it's raised the profile of IRC in a lot of people's minds. And so you get people who haven't been on IRC for 5 years going, oh yeah, I remember that used to be kind of cool. I don't know, there's been a little bit of an IRC renaissance. And so ironically, Tom Nardi's article was, is the death of Freenode going to bring IRC down?
Yeah.
And it looks exactly like the opposite. You're seeing a lot of people who haven't been there. And in fact, there haven't been this many people in the Hackaday IRC channel since God only knows when.
Well, and from reading your newsletter from last weekend, I think you're right that there are a lot of channels where that's the go-to place to get great information and great personal help from people that are just waiting around and want to talk about this stuff. I'm with you. Before I carried around a computer in my pocket, I lived on IRC. You had your channels and you were logging, and when you got home, you'd go back and look through the logs and see what people were talking about.
Exactly.
And if you got disconnected, then you're always sad because you're like, what did I miss?
Well, that's why you run a server. I mean, that's why you have your IRC client running on a server somewhere with good uptime. So you never miss anything.
I don't think you could just rent a server back then, though.
I've lived my whole life with an IP address. That can't be true. Since college, I've lived my whole life with an IP address.
Aha.
Anyway, none of this is the point. The point is, swing on by the Hackaday channel. We've got an unofficial Hackaday IRC channel. We used to have two of them on Freenode because two different people set up Hackaday channels. Now it's kind of coalesced it down to one IRC Hackaday channel on libera.chat, and it's called, unsurprisingly, #Hackaday. In other news this week, there was a new part day, an ESPW room or vroom -DA, and DA stands for dual antenna, and the thing has little Mickey Mouse ears antennas on it. The idea, I guess, is that it's a diversity antenna situation and they have to be at 90 degrees to each other so their patterns don't overlap. It makes a ton of sense. It's the weirdest looking module I've ever seen.
Yeah, I saw people calling it the t-shirt module because it looks
totally.
Yeah, like two arms of a t-shirt coming out. Almost like one of those baseball t-shirts where you have the white on the torso and then the colored sleeves.
Yeah, right.
And the sleeves are where the two antennas are. I'd like to know what's going on under the hood because my understanding is it will use whichever antenna has a stronger signal. So I'd like to know if that's done in hardware or if that's some kind of microcode or what's going on to make that happen.
Ooh, yeah. Maybe someone should pop the can on one of those and do a teardown as soon as we get one.
Yeah, I would love to have one.
Huh. That sounds like fun.
In this case, it's just a render. I don't think we have a picture of the actual hardware yet, but it's interesting. I mean, it's kind of go-to Wi-Fi device. And I was actually playing with the Bluetooth on the ESP32 this week. So you know how DSLRs have remote controls that are IR sometimes? So I have one of those, but who wants to set up a DSLR and then you have focus problems and this and that, and the cell phone is a really good camera these days. And so for the annual picture of the family, I actually made a Bluetooth keyboard on the ESP32, and you just map a button to the volume up key and pair it with your phone, and it will be remote shutter for your phone. And it's I did it with the Arduino IDE. It's I don't know, 20 lines of code max. And a lot of that is like, just setup stuff.
Oh, that's a great idea. Yeah, the only thing I don't look forward to about this crazy looking module is clearing out space for the antenna. If you have to like make sure there's no copper underneath the antennas or else they detune. This one's got now this weirdest footprint ever that you're going to have to like leave out of your copper pores.
Oh, but one of the people in the comments said they could see this on the corner of a board. So you just lop off your board design at 45 degrees,
yeah.
and then this hangs over and it continues the corner shape of the board.
Ooh, I like that a lot. All right. Well, look forward to seeing what people do with this Mickey Mouse module.
We can't start up with the hacks until we do What's That Sound?
This is a journey into sound. What's that sound?
What's that sound?
What's that sound? I was a little bit disappointed, frankly, in y'all. We got a grand total of 5 answers, of which 2.5 were right. And so I'm going to draw the line at the 2 that were most right. That sound was...
And here is the click of death.
And the 2 people who got it really right were Drew, Aiden, and John. And John's answer is also my favorite this week. It's click of death. Good grief, when it dawned on me, my spine tinkled again. So
I was reading the quote as you were reading. I hadn't read that much of it before.
I hear you, man.
Oh,
like
gosh.
I said, this happened to me when I was in graduate school, and the good news was we diagnosed it quickly, and the hard drive would fail and then work and then fail and then work, and I actually managed to image the whole damn thing during one of its I'm working periods and completely got away with it. But since then, horrors. Since we only have 2 winners and I was going to make a new random number generator every week, I think this is the perfect week to use a coin as my random number generator.
Ooh, that is a good random number generator. So let's see. If it's heads, the t-shirt goes to Drew Alden, and if it's tails, it goes to John.
That sounds fair. And I've got in my hands a 10-pence coin. And so it's got Queen Elizabeth on one side, heads, and some kind of funny lion or something on the other side. We'll call that tails. Here goes. It is tails.
So that is going to John. So look in your email box, John. Congratulations. This one must have been harder. We had many fewer entries than the last time around. And I would like to say shout out to my mom, who is not huge into the tech scene, but does listen to the podcast occasionally, and texted me and said, "That's a teletype."
Oh, no way.
One. Yeah. So I think this one was much harder, but I like it how they're generational, right?
I actually thought this one was going to be super easy. And so I even gave a hint. I mean, come on, peoples.
Yeah, that's why you got to stop telling me what it is. Because it, like, once I knew and I heard it, I'm like, well, obviously
You
that's
heard
the
it,
click of
yeah.
death. But it's hard to know if I would have come up with that. I do think it's hard. I mean, really, hard drives these days are super reliable. Like, this is much smaller problem than it used to be.
Knocking on wood and
Yeah, I
just
follow
crossing
that
my fingers.
I follow that Black Blaze puts out those hard drive reports, and I'm just consistently, my mind is boggled. You know, they're looking at hard drives used in servers. They're just driven and driven and driven, and they have failure rates of, I don't know, tens of thousands of these things, and the reliability numbers have just gone up and up and up. It's crazy.
Yeah, that is absolutely true. Is that hard drives have gotten better. I need to do my backups. Remind me to do that after we're done with the show.
There will be more What's That Sound to come, so keep listening to the Hackaday podcast in the future. But now, let's jump into the hacks.
All right, first up this week, I've got perfecting a 3D printed camera motion control rig. So this is a hack from Andy, and he's got some good videos of how it works and all up on his Fuzzy Logic YouTube channel, and you can see it in action there. But this is something he's been working on for at least a year now, and it's been going through a number of prototypes. And it's a 4 degree of freedom motion control rig, and it's got 2 parts. So one part is a slider with a 2 further degree of freedom rotation to turn and pan the camera around. And then the extra degree of freedom is really cute. It's a little rotating puck platter thing that sits on the table. So you can put whatever it is you want to video on top of this rotating platter, and you can have it turn while you can have the slider go by it, turning, panning, tilting around it. It makes these awesome, swoopy looking videos. This is a beautiful design because it's written up on Hackaday.io as version 0.1.0, but he's selling himself short here. This thing is mostly 3D printed except where it counts. And that is to say it's got slip rings and solid bearings. And actually, it's even got 2 angle brackets that screw into the 3D print that make it really rigid and strong where it has to hold the camera, which is important if you have like a 1.5 kilogram SLR rig dangling off this thing. It actually needs to be strong enough. And actually, if you go through last year's version of this project, one of his previous iterations broke right at that hinge that he now has reinforced with metal. But that's what's beautiful about this. You should really go and check out his old video from last year where he shows all of the different revisions where he made the mechanism in wood a couple times, like 3 wood prototypes, and then he starts making some plastic prototypes. And he is just refined and refined and refined. And the same goes for that little rotator puck thing. You should check out that video as well. I'll put links in.
It's so buttery smooth when he shows the demo. It's what I assume are renders when you have like a cell phone commercial. Like Samsung will do a commercial and they show the phone like large as life and the phone is like rotating while the camera like swoops up and behind it and stuff. I assume those are renders. Maybe those are actually happening. But either way, there's like some huge production company behind them. And this is Andy just doing, teaching a lesson in how this should be done because it comes out wonderfully at the end. And I also think, like the choreography, like knowing how you want to move it goes in there as well. I think it's cool to see that those slip rings are 12 signal slip rings, which I didn't know existed. And actually now I kind of want to look and see if he shared the part number on those. I don't know that I have a reason to use it, but it's good to have in the back of your pocket when you need it. On the video, he mentioned using Node-RED for like a web interface. Did you catch any of that, Elliot?
Yeah, we've talked far too much about the mechanical side. He also has a remote control that he built in a previous project a while ago that uses an ESP32, gets on his network, and sends the remote control button presses over MQTT. And that's where the Node-RED part comes into this, is that he's got Node-RED running an MQTT server on this Raspberry Pi that's inside this slider mechanism. And the other thing that's really cool about this all being networked is that the little rotator puck has actually got an ESP32 in it. It's connected to the network, and it's receiving G-code through Telnet. And so you telnet into this thing and then send the G-code directly to it, whereas the big slider rig is running its G-code directly out of the Raspberry Pi, and he reports that there is absolutely no problem synchronizing all these together. You just have to press go on the 2 G-code streams at the same time, and they run. What makes this all work is a keyframing system that he wrote himself. So basically you use the joystick to maneuver the camera and the tourney platform into exactly the positions you want. You press a button, and then you maneuver them into the next position. You press a button, maneuver it in the next, press a button, and then you say how long you want it to take in between each of these positions. And so that's how you get this kind of really nice looking effect where, it swoops into one angle and then it dwells for a tiny little bit at this one angle and then it turns around the thing and it can do that quickly or accelerating or whatever. This is actually all really easy to do in G-code. You're just putting positions for all of these 4 axes in there and telling it how fast you want it to get between them. But he's written some software that makes it really easy for you to input these values in there and then also easy to just play them back when you're done.
I spent way too much time looking at this project coming out of X Robots. That's James Bruton's channel. It is a new type of omniwheel for robotics. And if you think about an omniwheel, it's a wheel that can move in any direction. I usually think of mechanism wheels, which is like you have a traditional shape of a wheel where it would rotate on an axle, but then kind of at an angle around the outside, you have all these kind of little rollers, and that allows the wheel to move sideways, and the rollers will slide. And when you have 4 of these mechanism wheels, you can move the robot in any direction that you want, even though they don't really grip since they have this rolly part on them. This is not like that. This is a completely different design. It is a sphere, and it's a sphere that mounts on an axle straight through it, but it still retains the ability to roll in any direction. And so if you think about it, if you let the axle like freewheel, it can roll like around the axle shape itself. But then the ball is 2 hemispheres that attach into the center of that and have themselves a pivot point that is perpendicular to that axle. So if you move the axle like end to end or axially, I don't know if this is going well or not, those 2 hemispheres can turn. And at any given direction, you're going to be able to have this thing roll, even though it doesn't look like it should. You need to go look at this because it's a brain teaser. And the only place in which it can't roll is if you're at the tip of one of the hemispheres. So if you're at the North Pole of one of these hemispheres. And so the design has just a wheel or a little roller in there that allows it to roll on that. James didn't come up with this. This is actually from some research that came out of a university in Osaka. I actually went and found the paper because I was so impressed by it, and the paper was published way back in 2007. James, as he does, is, he likes to bring things to life and put them to the test. And so I think it comes alive a lot more in what he's done here. And he actually bootstraps it up to the point where he has 3 of these things on like a triangle assembly and is just rolling around the test rig and says that it, basically has no resistance in any direction that you want to go.
There's something really weird about this design, and I didn't appreciate it fully until watching James's demo. And that is that when the wheels are rotating at kind of their widest part, where these spheres are just cut in half, the wheel is rotating for a given speed as slowly as it ever will. So I'll call that the equator. And then as it's moving toward one of the poles, the circular path on the wheel gets smaller and smaller. And so when it goes to the straight up North Pole, which is where that little roller is, the wheel would have to be spinning infinitely fast to be rolling across the ground. And so you get this really weird motion where the physical thing is speeding up, speeding up, speeding up, and then it hits this little roller and it stops absolutely and glides on the roller. It is such a weird looking mechanism, but I'll be damned if it doesn't work and roll pretty smoothly.
Yeah, when he gets to the 3 on the rig, I'm like, oh, I actually contemplated buying a 3D printer so that I could build this and put it as the wheels on my desk chair.
I think you'll break these in a second. Does he have has he done a weight test on these yet?
What? Oh, I'm not that heavy, Elliot. Come on.
I think you weigh more than like the 5-pound robot he's strapping to this thing, dude.
Yeah, you might have to scale them up a little bit. But he did a follow-up video that just so this was published on Hackaday at the end of last week. And then James released a follow-up video on Tuesday, and I saw on Wednesday that Danny Conradi had written it up. And so I'm not sure if it's published yet or not because I saw it on the back end. But it adds motors to each of the axles on these. And so by spinning the axles in the right pattern, you can move in any direction. So you end up with a steerable robot, which is amazing. Even cooler though is I'm always like looking like polar bots, like the polar plotters, and I'm like, boy, how do you do the software on that? James actually goes in and shows you how to calculate how fast each wheel needs to move depending on the direction that you want to go. And he makes it, he's drawing triangles and he's showing you that, basically you swing the axle up at a particular angle, and then the percentage of that angle, the ratio of the triangle ends up being the ratio of the power that you need. So it's a really cool explanation. And, he says this is a great test platform for a robot, although he does then try and drive it over like some small obstacles. And like this thing is made for a gymnasium room floor. It's not really made for getting anywhere else. But as far as propulsion wheels go, it's amazing. And I would just like to go back to the article that I wrote back in November about, I think the gentleman was in China in what looked like a big cast iron, like fire pit ring, sitting in that thing with 3 wheels around it and driving, and the wheels would track in any direction. I'd love to see that thing rebuilt with these Omni wheels on it.
My next hack is RAM fiddling turns VGA converter into video synth. And this is a write-up of a project by Lo-Fi Future. It involves VGA circuit bending and tapping in directly to the pins on a RAM module and shorting them out to make funny video artifacts. Video synths are kind of an old idea going back to the 70s, and I think we actually did an article once on the Sandin machines. We should throw that link in the show notes. But here is a definitely much cheaper, much easier, and much more reliable way to make crazy random video art. The short version of the story is that he's got a VGA to composite video adapter that has a memory chip in it that he can solder wires to and tweak so that he glitches it out. He also takes a second composite to VGA adapter, doesn't modify it in any way, but plugs these two together so that they make a loop, so that he can do feedback between the two as well as put video signals in. And that's the trick to making all of those crazy, trippy, like video effects of days gone by. This is so fun to look at this because in kind of the digital era, I think we've totally forgotten about analog video synths, and it's fun to see someone rediscovering this whole art form, I guess.
Yeah.
And the coolest thing about this hack is it's based on a kind of cheap, it's about $20, a GBS 8100 VGA to composite adapter, so you can hack on one of these without worrying about destroying vintage video equipment.
Yeah, you know what? The Hackaday events, like Hackaday Belgrade and Hackaday Super Conference, I was looking at the video in the back, and I feel like I understand how audio synths work, and I don't understand how the video synths work at all. And so it's fun to look at this one, but I got to say it was the fabrication part of it that really stole the show for me. I mean, the enclosure that's used, at first I thought it had faceplates that were PCBs. You know, because that's a good way to do that, because you have the copper clad look, or the plated copper looks nice, and then you have your color of solder mask, and then you have silkscreen on top, and it makes a really good look. But then you have to order out and wait for that to come back. And in this case, it was just a modular plastic case, modular plastic enclosure, like for, I guess, industrial components, that had a piece of paper printed out and then glued on top, and then that includes cross hatches for where to drill. And it came out with just a beautiful look, even though on the inside it is a rat's nest nightmare of wires.
Yeah, so the hack itself is basically glitching out this RAM chip, and it's got, you know, all of the address lines and all of the data lines. And he does it just by patching it in. The top of this box that Mike just described is then broken out into banana jacks, and he can literally connect one line of this RAM chip to another by putting like little banana jacks in between these and pressing some buttons to send them high or low. That's really awesome, and like it makes this a low-tech, no-tech type project. But it made me think, what are all the crazy cool effects you could do if you had a microcontroller driving the show? You could get the mind boggles. Like, you've got all this video in this RAM chip. All you have to do is manipulate the way it plays out by tweaking with the address. If you can tweak the addresses, you know, conditionally on where they are, you could do multiples and kaleidoscope effects and everything else. This is beautiful just for what it is. And I think for the very low-tech approach and for the low price of $20 and some heavy-duty soldering, this is a beautiful little project. If you want to see how far you can push some of this like old school analog video art, I stumbled into a YouTube channel along the way from Yovozol, and I'll throw the links in there. You should absolutely check out his work. He's using basically the same equipment here, slightly fancier and getting some really great results. So if you want to investigate in throwing your own microcontroller in here, that is a good list of like some of the canonical crazy analog video effects that you can use to your advantage.
I'm pretty sure we've talked about this CNC project that Andrew Consrow is working on. It is a scroll saw, which I think is quite a bit more difficult than some of the other machines, as at least for me to wrap my head around. And one of the challenges of working with the scroll saw is that the blade deflects a little bit as you cut. And that reduces the precision. And on a CNC machine, precision is everything. And so Andrew's come up with a really fascinating way to precisely track what's going on with that blade. And it's a periscope. So you actually put a camera below the work surface and you use this setup of mirrors in order to get, I don't know, did you call it binaural?
Yeah, right?
Binocular view of it. It splits two views of the blade into one camera sensor. In this case, the high quality Raspberry Pi camera with a nice lens on it. Elliot, one of the most amazing parts is having the explanation of how the design was kind of mocked up and then ray tracing was used to get an idea of what the optical path would look like. The mirrors themselves come from hard drive platters. So he just tapes a hard drive platter over with like painter's tape and then saws through it, maybe with one of the blades from his machines. And the reason he's doing that is then you get first surface mirrors. So if you use a mirror that you just buy on the street,
right,
from the mirror man down on the corner, you end up getting a piece of glass that has the mirroring on the back of it. And so as light passes through that glass and reflects off the mirror and then passes off the glass again, it kind of warps it has an effect on the path of the photons. And when you're trying to get precision again, that's not great. And so these are used as the first surface mirror so that the light reflects off of the first surface it hits rather than making that transition from air to glass and back again.
This thing looks a little bit in use like those old rangefinder cameras where like you have two visions of the same line and when they line up, you know you're in focus. Except this is the same thing, except I guess you know you're not deflecting your saw blade.
There's some good conversation on this, on what the effect of using this is going to be. It could be that you just calculate where the blade is, but it could also be that you use the deflection feedback to change the feed rate so that you're not deflecting as much. I am interested in how to deal with that from a software angle. And on that point, Andrew goes into the process he used of homography in order to map the measured deflection of the blade to the actual observed pixel positions from the camera so that the data that you're processing from the camera view precisely maps what's happening in the real world. It's a great project, well worth watching the video, so go take a look.
Well, from one elaborate machine to another, this one is a robot arm adds freedom to 3D printer. This is actually a video on the computer file channel of a research done by Feng Zhou at the University of Nottingham. And he's got a 6 degree of freedom robot arm, one of those kind of snake-looking ones. And he's put an extruder for a 3D printer on the end of it. What does this let you do? It lets you move the head in arbitrary ways, kind of coming in at the print from arbitrary angles. He's got an extremely pointy 3D printing head on this, so he can print sideways. His idea is to do not just non-planar layers, but if you're using a filament that has a string-like thing in it, like maybe it has like a carbon fiber in the string, in the filament, if you just did it in the normal 3D printer way, which is really kind of 2.5D, right? You go layer, layer, layer. There's going to be a weakness across the layers. And so this is attempting to go up and down as well as side to side at the same time. And if you're using a strong reinforcement in there, it's going to make this print structurally stable in new and unique ways. We've seen a couple non-planar 3D printing hacks over the last 5 years. Actually, I was first tipped off to the idea by an article that Moritz Walter wrote for us, which was really neat. It was 3D printing, non-planar layer FDM. A great article. You should absolutely go check that out. But then in just the last year, we've seen a couple other research groups working on this sort of thing, including a 5-axis machine that I'll link in here, and then another with a 4th axis that's offset at 45 degrees that I know we talked about on the show a few months ago. This was the one that was printing overhangs by rotating around the piece and printing out these cones. I actually just recently found the code for that slicer that does that, and so I'll throw those links in there too. I think that's where the limiting factor is right now. I think there's tremendous opportunity in this non-planar 3D printing world, but right now it's all sitting waiting for the code to kind of catch up with the machines, right? Like if you can just take a 6 degree of freedom robot arm that you just bought and strap a 3D printer on it, you're good to go. The question is, how do you drive it to make the optimal path? And that's where I think the rubber is going to meet the road. And I think that's where the neat advances are going to be over the next 5 years.
So I've always been excited by the Ambilight idea. And this is the thought that behind your TV, along the top edge, the bottom edge, and each side edge, you would have a bunch of addressable RGB LEDs that would light up matching that part of the screen. So it's almost like the colors at the edge of your screen project on the wall behind the TV, and your whole room kind of gets this like effect of what's going on with the media. And when I saw this one, and the title is Roku TV Hacked to Run Philips Ambilight Setup, my ears perked up immediately, because the problem with these is you have to be able to analyze the frames. And on a lot of things, getting those frames is difficult. Like for instance, if you have a Blu-ray player and you connect it to your TV with an HDMI cable, my understanding is there's some kind of encryption, copy protection, whatever at play. That means you can't just like put an adapter in between those two of those and read bits that are going through. And so I was excited to dig into this. And there was a comment from R. Pavlik on this article that sums up what you need to know about this. And the comment is, "Holy moly, the ambilighting here is just the cherry on top. This is really, quote, how I rooted my Roku-based smart TV, then used the dedicated hardware in it to spy on myself the same way it spies on me," unquote. And that is the truth. So the way that this worked is the Roku was rooted in order to pull out the frames that there's like a built-in spy device, surveillance device, tracking software, some, insert your evil thing here. But basically, there's a mechanism by which frames from what you're viewing can be sent back to the Roku headquarters evil lair and used for some marketing purpose. I think you can turn it off. I'm pretty sure I have it turned off on my Roku TV. I'm not sure. But the journey to get there is what's entirely fascinating. I did not realize that there's a developer mode on these, obviously, and that you write in a script that is somewhat based on the basic programming language.
Oh, lovely.
Yeah, it's really crazy. It's called BrightScript. It has the interpreters that you can type in and see stuff coming back. Amar Asghar does a great job of explaining. The hack itself kind of boils down to the ability to use the curl command on files, and ended up not being able to get out of the sandbox, which is the point of it. Your app is only supposed to run in your little defined area on the device. You're not supposed to be able to get to other people's files. But Amar figures out that they did not sanitize % encoded URLs. And so if you look in the URL line when you have like a space or a quote or some other special character, you'll have like a %20 or a %, whatever. And that corresponds to another figure. And so in this case, the % value for period was used. And so a double period in Linux means go to the previous directory, like go up one directory.
Boo, directory traversal.
Yeah, I was able to do directory traversal to get out of this. And then better yet, ends up being able to pass out the entire squash file system and then boot it up in Hedra, and you get the passwords out of it and get persistent root on it. And then reverse engineer this part of the program that is pulling frames out, and then chop those frames up into a bunch of different zones around the edge of the screen and pass those out for, I think it's a Raspberry Pi, then interprets them and then lights up the LEDs the way that you want it. And I think one of the most pleasing parts of this is it goes beyond the LEDs on the back of the screen. There's a lamp that's got RGB LEDs in it on a desk over to the right. And then there's some kind of like, I don't know, ceiling projecting lamp or something over to the left. And those change to match the color on those sides of the screen as well.
No, I didn't even look at this one because I don't even care about TV. Now that I'm looking through this is a phenomenal bit of hacking.
Oh,
This is a hacky hack, but for real. Oh, hat tip, Amar.
Well, and what's funny is when it was published last week, I started up the agenda for the podcast and put this on there. And then just before we were getting ready to record, I went to put the rest of the stuff on there. I put this one on there again. So this one is endorsed by me twice.
My first quick hack this week, NeoPill is the NeoPixel emulator you've always wanted. Randy Elwin has convinced a blue pill board to sniff on a NeoPixel /WS2812 data stream, pass it off to your computer by USB, and then he's written a Python program that displays the lights that would be displayed on your computer screen. Why do you want this? Maybe you're developing something for a whole bunch of LEDs and you just don't have a string on hand. You want to emulate it on your screen. It'd be awesome to play around with the graphics, get those right, and then take it to the real hardware. Next up, ThinkFlight. Ground effect drone flies autonomously. This is a wing-in ground effect video. It's also a lovely airplane build if you're into model airplane things. This is a lovely tech demonstration on one hand, but you should also check out the unpowered versions of this airplane also on his ThinkFlight YouTube channel. They're the kind of thing you could just put together out of paper and play around with this ground effect on your own at home. Last up, Xylofoxlin has a video, a high-power wooden rocket in 5 days. The wood bit is a little bit of a clickbait here. It's actually just a wood veneer lovingly put around a normal rocket tube. On the other hand, don't let that discourage you. What the video really is a lovely beginning to end construction video of all the details you need to make a fairly beefy rocket that can successfully return to Earth. This is not your normal model rocket. This is a level 2 certification test rocket. She's already into kind of phase 2 of the rockets that are so big you need a license for. So there's some real tech here. She also gives you some pretty neat use cases for why you might want to consider adding glitter to your epoxy resin.
First up on my list, Simple MicroPython Game is a 30-minute game dev course. I like this one because it's using one of those Wio terminals. I think this is a Seed Studio part. And it looks like, a consumer good that you would be hanging on your wall with a little color LCD screen on it, a nice little case, and a joystick for user input. I mean, it also came to mind like the M5 stack, which I think those are running. I think those have an ESP32 inside of them. These Wio terminals have like a SAMD controller inside of them. But both can run MicroPython, and I think it's really fun to get someone into embedded engineering with these kind of consumery, flashy looking devices. And then what's better than coding up like a mashup of Space Invaders on one of these? So if you have a half an hour this weekend and you want to try out some new MicroPython stuff, that is the place to start. Next up, if you want to drill way down on your C code, you want to have a one instruction compiler. And to me, it's kind of like if you could only make left turns for the rest of your life. So it's like, what would your code look like if you could only use one of the move instructions for everything? That's kind of a mind bender to figure out how you do that, but it is possible. And finally, we have Terminal Magic with Not Curses. This project by Nick Black re-envisions like the N curses, which is that, I would say, is it ANSI characters? It's, like you can do different background colors and foreground colors and make up menus on the Linux terminal using N curses, Well, this says that is for last century. If you're doing, user input on the terminal in this century, you want to have full motion, pixel perfect graphics, and the not curses program will get you there. It's time for our Can't Miss Articles of the Week. This is long-form content written by excellent Hackaday authors. What'd you pick this week, Elliot?
This week, I picked Al Williams's Getting Started with Aluminum Extrusions. I think aluminum extrusions are awesome. They're definitely super tempting. They're a little bit pricey sometimes, but they offer you this tremendous building flexibility. Have you ever built stuff with aluminum extrusion, Mike?
Never. I've seen it. I've read about it. I respect it, but I've never taken the plunge.
Yeah, you should get yourself a 10-pack or something. I know I found a sale on a 10-pack, literally a 10-pack of half meter and meter cuts of aluminum extrusion. And it is handy stuff to use. Basically what it affords, and Al gets well into this in his article, is you can put screws anywhere along its length and you can screw something down and then unscrew it and then screw it back down again. And it's kind of infinitely adjustable. And that's why you can kind of build anything out of them. It's aluminum, so it's thin and lightweight. I tend to knock up frames like this a lot of the time in wood because wood's really easy to work with. But compared, for stiffness and for strength, compared with aluminum, it's a lot bigger and bulkier and frankly flimsier. And so if you're building a machine, there's a reason all the cheap 3D printers are made out of extrusion these days.
Well, and the thing that's always been fascinating to me, and I don't own one, but 3D printed connectors for these are all over the place. So you can find designs to do just about anything. And I think what sticks out in my mind is the article that Roger Chang wrote, basically looking at the connectors that he had 3D printed for his SOPI rover project, something that has been incredibly popular and has been built by a ton of different people. And there's a picture of it in this article, and it looks amazing. I mean, it looks like NASA engineering because that's what it's supposed to be.
Well, he copied it right off the open source rover files. Yeah, no, it's a fantastic project. And both Al and Roger drive this point home that aluminum extrusion is awesome because it gives you strong and straight, and you can tighten something down to it basically anywhere along its length, but it's all 90 degrees. It's all straight or right angle. And so that's where 3D prints come in. You can make corner joints and angle plates and all of this at kind of arbitrary angles and get away with it. I've never built anything permanent with it. I always build something up, use it for a while, take it back down. So I've still got the same 10-pack in various pieces all around my house and could build something else out of it again if I needed to. I think that's a good perspective to have on the stuff if you haven't indulged in buying a whole bunch of it. It's maybe extrusion's a little too expensive for this project, but if you unscrew it, you can use it in the next project too. So you kind of have to amortize it over the life of you building frames in your mind.
So let's talk the chip shortage, Elliot.
Oh, man.
This is above just the geek drome, right? This is world over been reported because the shortage of silicon chips has been shutting down automotive assembly lines. It has been disrupting the flow of consumer electronics. And Jenny List wrote an Ask Hackaday article, How is the chip shortage affecting you? And we had a ton of people write in for this. I was really interested to see that Arthur Wolf was right at the top there, who was talking about a new smoothie board design that had been kind of, already figured out and was headed to make a production run. And they can't get the LPC 4330 controllers that are going to be at the center of this board. And so they are frantically moving on an effort to redesign with an STM32H7 microcontroller, which as soon as I read that, I was like, whoa, I hear everyone's out of STM32 microcontrollers. And someone replied to that, and Arthur said, yeah, we actually bought as many as we need for this production run, and we might be contributing to the shortage now of that microcontroller. And that's the thing, is that it is dominoes. that are falling down because everyone that has projects in the works that runs into a shortage are then branching out to another product that they maybe wouldn't have been ordering, which means the demand for that product goes up. And then people who were counting on that stock to be there then have to themselves pivot and go to something else. And it seems to be compounding itself.
I'm looking pretty good with my giant collection of 555 timers right now. I'm ready to build anything.
One of anything that you need is what Elliot can build you.
Yeah, that's about right. No, I have some chips in ridiculous, embarrassing overabundance. Don't you worry about me. No, I think this is a real interesting issue, and it's definitely affecting, the global economy in a serious way. And I think on one side of it, we hackers are kind of getting the short end of the stick here because we aren't able to make multi-year contracts with semiconductor manufacturers like the auto industry is. And so, for all of the stockouts the auto industry has, they're also, to some extent, making the situation harder for those small players of us out there by having these really long-term contracts running that say, you ST or you NXP have to supply us next year with whatever. On the other hand, we also don't need parts in 10,000, 100,000 quantity either. So it is, I guess, possible for us to pay these stupid, horrible markups that you're seeing for chips in single quantity and get them. But ouch, that hurts too.
Yeah, what's interesting to me is that I've heard of government contracts where they will require a certain amount of engineering hours be available at any time under their contracts. And so you literally have engineers who are being paid to just be there, even though there's no work to do. And I wonder if we'll start seeing that built into chip contracts going forward from this because it is so disruptive to have these missing. I also wonder if the just-in-time system will go out the window as far as microcontrollers go for some industries. But I think that's a long way off. I'm still, we're in the thick of it now, and I think it's still maybe compounding in severity. I was interested to hear a couple of people say that they're having trouble getting passives. So they're seeing shortages in surface mount resistors and capacitors. That's something I remember. Gosh, it must have been 2018 super
a few
conference.
Years back we had
yeah.
these. Yeah,
it was one of the badges that Macrofab did the contract manufacturing on. We had to swap out some parts because there were shortages, but that is such it's a much easier problem to roll with because as long as you have the right resistance, you might change the dimensions of the package. It's a lot easier to do that. But if you're going to go to a different buck boost converter, you may have a different pinout, a different footprint for it. You may have different supporting components that go on it. It becomes a lot harder the more complex of the chip. I mean, obviously, I think everyone listening knows that.
And then you change your microcontroller and you have to port your entire software over to a different line of microcontrollers that has a different peripheral set. I mean, ouch.
There's also a couple of conversations about materials. So I was surprised to see a couple of people talking about copperclad and FR4 shortages. You might need to change the dimension of the board. Again, this is anecdotal, right? But that's one of the reasons we've had trouble writing about this is how do you get definitive, reliable information on the shortage? And one of the ways is just to ask the people doing the design. One person in here talked about packaging problems and that they're having trouble getting their flip chips VGA packaged. And I know that I talked to someone who I don't know that I have permission to say who it was, so I won't. But they were saying their company has enough dies for what they're making, but that the supply of bonding machines and packaging machines is tightening up.
Yeah, it makes you start looking in your junk bin and thinking, what can I take off of this? And, am I going to need to scavenge voltage regulators off of dead Arduinos?
Yeah, I would not be surprised if you see people who are doing prototyping who are salvaging things. And they're okay, well, I can't order a lot of those. So for my prototypes, I'm going to kind of use what I have around and then hope that the supply comes in by the time I need to do a production run. But, when you're talking about someone said they thought this would settle down, was it 10 to 20 months, they said?
Oh, that's 2 years, people. This whole thing is just so post-apocalyptic, so like Mad Max. I can't even begin to say.
So if you have stories to share, we'd still love to have them there. You can find the show in the show notes. And boy, I hope that it starts getting better. But hang on, we're in for a wild ride this year. That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you do something cool or you see something cool, please tell us about it. tips@hackaday.com. And until next time,
keep on hacking. I got a thing here.
I would wager you want me to turn off my ceiling fan. I'm now sweating for the audio fidelity.
Boo! Super boo.
First up on my list, simple micro... maybe that wasn't good to say. How do we get out of this episode?
That was lovely.
That's how you end it? I wonder why I do that every week. We should just record it once.
We keep it fresh, man.
Keeping it fresh. Omniballs.
I'm naming my next child Omniballs.
Stop.